Hello again, we are here with the third chatbot from LLM 0 to 100 series. In the previous two videos, we designed two chatbots. So let's quickly see what we did so far. We designed RAG-GPT. RAG-GPT was a chatbot that enabled us to chat with our own documents. So first, we processed our documents and created a vector database. And then in the chatbot, we could immediately start asking questions from our documents. But more than that, we could have uploaded documents while we were chatting with the chatbot. And finally, we could pass a document to the chatbot and it could give us a summary of the whole document in one inference. Then we designed Web-GPT. Web-GPT was a chatbot that could search the web and give us the answer. So what we did was we gave access to a search engine, to a GPT model, and that GPT model could make a decision whether to use its own knowledge or to search using the search engine and give us the answer. Now we are going to combine these two chatbots and create a new chatbot called Web-RAG-Query. So this is the chatbot that I really like. Actually, this chatbot I often use for my personal use cases. And if you, just like me, ever searched over the web trying to find something, and you just crossed over a website that contained a lot of information. What I always wanted was a chatbot that can do things. Either summarize the website for me or let me ask quick questions about the content of the website. So Web-RAG-Query is going to do both for us. Let's quickly see the functionalities of this chatbot. So there are a lot of things going on here, but for now, let's focus only on this part. This chatbot can do four things. First, it can use its own knowledge. The GPT model here can use its own knowledge to give us the answer just like a simple ChatGPT. Then, it can also search the web, use the search engine, search the web, and give us the answer from the web search results. So it is going to have all the features of Web-GPT. Then, what it can do is it will be able to go one layer deeper and prepare the content of the website in a vector database so we can start asking questions about that website. So this chatbot is going to have a RAG system next to it, but this time, instead of asking questions about our documents, we can ask questions about the content of a website. And finally, this chatbot is able to summarize the website in one inference. And if you just go into a website and there are a lot of content, a long piece of information, you just want to quickly understand what is happening in that website, this chatbot is able to do it for us. One more thing is this chatbot is going to be designed using Chainlit. So since this series was started, I said that I'm going to design each chatbot using a different user interface. So I designed RAG-GPT using Gradio, and I designed Web-GPT in a Streamlit. So Web-RAG-Query is going to be designed in Chainlit. Before discussing the code, let's see a quick demo of the chatbot and test all the functionalities and see how it works. This is the user interface that we are going to design for Web-RAG-Query. And for the first prompt, I'm going to ask a question from the model that makes it to use its own knowledge. And one of the best ways to test it is to just simply ask the model to fix a code for us. So here I'm asking the model to fix this code. I'm passing the model the code and the error that I'm receiving for this code. What I expect is the GPT model, just like ChatGPT, explains what is the source of the error and gives me the corrected version of the code. Then for the second prompt, what I want to do is to replicate what we created in Web-GPT. So I just want to ask the model that I am looking for videos that explain how to speak, let's say, French. So this is what we designed in Web-GPT, and what the model is doing right now, it is using a web search engine. It is searching our query, and it is giving us some relevant links that can be from YouTube or any other sources, but it explicitly is going to search for videos right now. Let's see some of the search results. So I have this video that's 7-minute French speaking practice 68, and let's open a new one, which is the same video, but number 72. So this is perfect. This is exactly what we expected from Web-GPT, and this is one of the features of WebRAG query as well. For the next prompt, I'm going to ask the model to prepare a website for me so I can start asking questions. So for the website, I'm going to point to the main page of Hugging Face, and it doesn't have a lot of content, but it is good enough for us to see how the model works. So if I ask the model that prepare this URL for Q&A, so now the model is going to go through the website, create a vector database from the content, and it comes back to me as, sure, the URL content was processed. Please start your question with 2 stars if you want to chat with the URL content. So the way that I'm going to distinguish a normal chat behavior from a RAG system is just simply by adding 2 stars in the beginning of a prompt. So if I ask, what are the open source models? Now it is going to search my query on the vector database, and it's going to pass the retrieved content to a GPT model, and that GPT model is going to give me the answer. So we can see here that it is providing me with Microsoft, Grammarly, and Winter Enterprise, which are not actually what I was looking for, but now this is the answer that I was expecting. However, if you remember, first let's double check if Microsoft and yes, so we have actually Microsoft 265 models, we have Grammarly 6 models. So in the RAG system, if you remember, one of the things that we said we are going to do is we wanted to stop the GPT model from using its own knowledge. So probably this is something that you can change with this chatbot, and you can test it to see how, if we let the GPT model to make a decision based on the response that it's receiving, it might actually improve the performance. But essentially what we want with the RAG system is to explicitly find the answer for our query without the model interfering with the retrieved content that it received. So here the GPT model received all this part here, which contains the information about the open source models, but the answer also includes Microsoft and Grammarly. So this is how we can prepare a website and ask questions about the content. Let's see the fourth functionality of the chatbot. For the fourth functionality of the chatbot, as I said, it is able to give us a full summary of a web page. And for that, I just want to pass LLM0200 GitHub repository. So this is the repository that I started to develop for this series. And as you can see, this repository contains multiple projects and it has a lot of information. So it is not a simple summarization for the model. And actually, if the model wants to give me a good summary, it needs to be able to start summarizing from the very beginning of the descriptions till the end. So let's see how the chatbot is able to give me the summary. So if I just simply ask the model to summarize this URL for me, the model is going to go through all the contents that are within that URL and come back to me with an answer. The GitHub repository you mentioned is a collection of various use cases for large language model chatbots. It includes projects like Web-GPT, RAG-GPT, WebRAG query, and multimodal chatbot. So there is one thing, let's see, because I still haven't included multimodal chatbot project yet. It is under development and it will be added soon. But the model clearly saw somewhere that that project exists. So here it is. I actually included a little bit of the description. So that's why the model thought the multimodal chatbot is also part of the repository. So that's still a very good answer. To get started with the repository, you need to clone it to your local machine. This is amazing, right? So it also explains how you can execute the project. Please note, this is a summary of the information. For more detailed instructions and information, it is providing me with a link to the GitHub repository. So this is how the model is able to also summarize a website for us. And this is the fourth functionality of the chatbot. So we just saw how the chatbot can behave as a simple ChatGPT. It can also use a search engine and search our query on the web and provide us with some relevant response. It can prepare the content of a website so we can start asking questions from the content, just like a RAG system. Actually, it is a RAG system that we are going to design for it. And finally, the model is able to summarize a website for me and give me a nice summarization of what is happening in that website. Now let's walk through the project schema and see how it works in detail. Our chatbot also has a memory. So the models that give me a final answer, which are this one, this one, this one, and this one, depending on the functionality of the chatbot, are going to have access to the chat history. So again, giving them the access to the chat history, we are able to have a nice, continuous conversation with our chatbot, and it will be able to pick up the previous Q&As, so it understands if we ask a follow-up question or if it needs to use something from the previous Q&As. One thing is, since the chatbot has 4 different functionalities and the same functionality is not going to always be triggered for each query, what I needed to do was to store all our memory in a separate file, and then for each query I'm going to retrieve the chat history from the file and pass it to the model that was triggered for that new prompt. So I will explain how the memory works when we are working with the code, but for now I just wanted to mention that we also have a memory, but for simplicity I'm just showing it like this. It just, if I wanted to add it to each model, it was just going to make it very complicated. So let's see how the first scenario works. The first scenario is when the chatbot decides to use its own knowledge. So I pass a query to my chatbot. That query is going to be passed to the first GPT model. That GPT model, which this one is probably the most important GPT model because it is the one that distributes the work and chooses the path, at least to 3 of the functionalities. So this model has a very important role, and this model has to decide what to do in order to give the user the best answer. So one of the things that it can do is to use its own knowledge, which is going to be the blue scenario. So if this model decides to use its own knowledge, it is going to go through this path and it's going to just directly give us the answer using its own knowledge. But what if my query needs to be searched over the web? So we want to have the exact behavior as Web-GPT here as well. And for that case, as we designed Web-GPT, this model is going to give me a function in the output that can search the web and give the user the best answer. So if I'm searching for videos, it's going to give me the function that can search the videos on the web. If I'm searching for images, it can give me the function that can search images on the web, etc. So this is the red scenario. So I pass a query. This query is going to be fed into GPT function caller. This GPT function caller now is going to give me a function in the output. That function, if you remember from the Web-GPT project, it is in JSON format. So what I have to do is to convert it into a Python format, execute it in Python, get the results, and then I will pass the results to GPT Web. So this GPT Web will have access to the user's query, to the web search results, and to the chat history. And then it can give me the answer for my query. So this is the second functionality of our chatbot. The third functionality is if I ask the chatbot to prepare the content of a website so I can start asking questions about it. So this is the RAG side of this project. I pass my question to the chatbot, it goes to the first GPT function caller, and now again it is going to give me a function in the output, but this time I know exactly what that function is and I know what that function is going to do. So that function is going to load the website and chunk the content. Behind the scenes, it's going to pass the content into the embedding model. I'm saying behind the scenes because I'm using LangChain. And as we saw in RAG-GPT, you don't necessarily see the embedding model directly, but you have to pass your embedding model to LangChain. So it passes all the contents to our embedding model, gets the embeddings, and creates a vector database and save it locally for us. So as soon as we have this vector database ready, what we saw in the chatbot was it gave us this answer. Sure, the URL content was processed, and now you can start asking your question. So as soon as we saw that response, we know that we can start asking questions about the vector database. The only thing is we have to start our query with 2 stars. So I pass my query. Then in the first step, we are going to check whether the query starts with 2 stars or it doesn't. If it starts with 2 stars, I'm going to double check whether the vector database was created or not. If the vector database does not exist, I'm just going to simply treat that prompt as a normal prompt. If the vector database exists, I'm going to vectorize my query, perform a vector search, and then retrieve some contents, pass it to another GPT model. So again, this GPT model is going to see my query, the retrieved content from the vector search result, along with the chat history. So it is going to give me the answer based on the content of the website. So this is the RAG side of our project. So for the second and third scenarios, which is search the web and query a specific website, I've already designed 2 chatbots, RAG-GPT and Web-GPT. So Web-GPT is exactly the red scenario, and RAG-GPT is very similar to the RAG side of our system. The only difference is in that chatbot, we were using our personal documents to have Q&A, and here we are preparing the content of a website. So if you still have difficulties understanding what happens behind the scene and how we can make it happen, I strongly recommend you to watch those videos. I went into details and I explained everything in those 2 videos. Finally, we have our fourth functionality of the chatbot, which is summarize a web page. So if I just face a long web page and I want to have a quick, nice, short summary of the website, what I can do is I ask the chatbot, summarize this URL for me. It is going to pass that query to the first GPT function caller. That GPT function caller again is going to give me a function in the output in JSON format, and that function I already know what it is. So that function is going to load that URL and is going to start passing the pages of the URL to a GPT model, and that GPT model is going to summarize in each page. And then I will have a list full of the summaries, and I'm going to pass it all at once to another GPT model. So that GPT model is now going to give me the answer. So this is a short description of what is happening in the project. As you can see here, the project is quite big. What I want to do is to open the code, open the project, and explain each scenario in detail and tell you how it is happening in our project. Now let's see how the code look like and how the project can be executed. So this is the project structure, and let me actually close this. So quickly, this is the folder that contains all the configs. I have used the same project structure for RAG-GPT, Web-GPT, and this one, so you should be able to quickly understand how the project looks like if you have watched the previous videos. You can start playing around with these configs here, and you can actually massage the system roles specifically to improve the performance of the GPT models that are working in our project. You have the data folder. This folder is going to contain the vector database in case we ask the model to prepare a website for us. Then we have the memory folder. So the way that it works is as soon as you open a new session in your chatbot, a new CSV file will be created here. That CSV file will also contain the timestamp, the Unix timestamp of when the session was started, when the chat session was started. So this is how I'm able to pick up the last chat history, let's say the last CSV file, and then from there I can pick up the last number of chat histories that I want and pass it to our model. So one thing is I'm just keeping the chat history fully here because I was thinking maybe you want to actually have access to your previous chat histories, your previous sessions. So this is how you can search what you discussed with the model earlier. And then we have the source folder that contains our main application, our main chatbot, and we have the utils folder. I will explain the code in 2 different ways. First, I will go back and forth between the project schema, and I will go through one of the scenarios here. And here I will show you where you can find the corresponding code of that scenario. Then in the second part, I will go through the app.py, the main module of our project, and I will again show you how those 4 functionalities can happen. So let's see the first scenario here. The first scenario, as we discussed, was when this GPT function caller decides to use its own knowledge. So if you come to the project, in utils, you are going to see a module called LLM function caller. If you open this module, you will see the class LLM function caller. This class has 2 functions. The first one is prepare messages, which prepares the input of that LLM model, the LLM function caller. And then we have ask, which simply passes the input to the model and gets the response from it. So this model has 2 options, whether to use its own knowledge or to call a function. For the second, third, and fourth behavior, what we expect is this LLM function caller calls out a function that we processed and we gave it. So let's see how that happened. I will open few modules and then I will show you how each one of those scenarios can happen. So we need a web summarizer, we need web search functions, we need this one and this one, and also this one. So if you remember, for function calling, I explained how to convert a Python function to a JSON format that is understandable for the language model, for a GPT model, and how a GPT model can give us in the output a JSON function that we can convert to a Python format and execute it in our Python. So it is a loop that I explained both in Web-GPT and the tutorial, and I explained function calling in detail. So first, let's see how we define the functions, and then we will see how we convert the functions for the model, and then I will show you how we get the response and we execute it in Python. So the functions for web summarization is designed here in Web Summarizer module. So if you open the module, you will see a class called Web Summarizer. This class has 2 methods. The first method is summarize the web page, which receives a URL, and it loads the websites, it chunks it, it passes it to a first language model. The first language model summarizes each page, and then the second language model gives us the final summary, the full summary of the website. And this is how I'm calling the language model. And as you can see, the GPT model here does not have the functions and function call arguments. So this is one of the functions that I'm passing GPT function caller, and this is the argument that I expect GPT function caller to be able to extract from the user's query. So if I say, summarize this URL, GPT function caller will understand that it should call this function, and it should be able to extract that specific URL and pass it to my function here. So my function first goes through the URL. I am using web-based loader from LangChain to load the content and to load them as a list. And then I'm going to just start looping over the documents, passing them to a language model, get the summary of each page, and then finally I'm going to get the final summary of the whole website. Then I have web search functions. So these are the list of the functions that we used for Web-GPT as well. As I said, I'm not going to use all the functions just to make it a little bit more simple for the model to decide. I mentioned in the previous video, so when you are designing these type of systems, technically what you're creating is a GPT agent or a series of GPT agents that are able to understand what functions to call, and they are able to extract the necessary argument and pass the arguments along with the function to you. So if the system becomes too complex, GPT models will start to struggle. I'm using GPT 3.5, so I expect GPT 4 to be more powerful, but the point is this is an ongoing domain and there are a lot of research around it. However, right now, if you start pushing your system, you will see that there are limits to the point that you can design a system, and you need to be creative. You need to make it happen by engaging like different ways that can simplify the whole process for your GPT models. So I have different functions that can search different content over the web. They can search video, image, PDF, etc. And these functions, you can see the docstring with the function, the explanation of the function, the explanation of the arguments, and what it returns. These are another set of functions that I'm going to process and pass to the GPT function caller. Then for preparing the website for Q&A, I have two modules. The first module is prepare URL vector database. So this is a class that, just like RAG-GPT, is going to get the content of a URL, load the web page, then it's going to chunk the documents, and then it's going to prepare and save the vector database. But in order to execute it, I'm creating this class here, URL prep, that creates an instance of that class and prepares the vector database for me. So what I need for this class to be executed again is the requested URL by the user. So again, the model sees this function here, prepare the requested URL for Q&A, and it knows that what this function needs is the requested URL by the user. This is how I created this part. So the green part is happening using these two modules. Then I have to prepare these functions and pass it to our GPT model, to this model here. So let's see how I'm going to do it. I have a module called a class called prepare functions in functions prep module. This class contains different methods that makes it happen for us, that process the functions, all the input functions, and then we can pass them to a GPT model. This class also contains this method, which is able to receive a GPT model's response. So it gets the response, it extracts the function from it, and it executes the function. So let's see how this works. First function is JSON schema, which receives a function, a Python function, and in the output, it gives me the JSON format of that function. Then I have wrap functions. So this wrap functions is going to be the input of my GPT model. So in the input, I need to pass a list of all the functions that I want my GPT model to have access to them. And this is what this function is doing. So this function is preparing summarize the web page, which is for the purple line. It prepares retrieve web search result, get instant web answer, web search PDF, and web search video. So 4 functions for the red scenario. And it also prepare the requested URL for Q&A, which is the green scenario. So I'm preparing all those functions and I'm converting them to a JSON format so the GPT model can understand and can call them whenever it is necessary. Then I will pass these functions to a GPT model, and in the output, in case the GPT model gives me a function, I will pass that response to this method here, execute JSON function. It is going to extract the function name, and it is going to compare the function name to the functions that I have in the backend. And in case there is a matching, so for instance, in case the function that our GPT model gave us was summarize the web page, I will check summarize the web page, and then as a result, I'm going to execute summarize the web page function that I just showed you earlier here. I also added some error handlings here. So in case the GPT by any chance gives you a function that does not exist in your backend, you're going to see that actually GPT made a mistake. I never saw that happen, but anyway, this is something that you might want to double check and make sure that your system always behaves as you expect. So I explained the blue line. I explained the functions for the red line, the purple line, and the green line. And I also explained how we process these functions in order to pass them to a GPT model. And I also explained that in case this function caller give us a function in the output, how we can process it in order to execute it in Python and get the results. So let's see how the whole system works in our application. So this is my application, and from the top up to this point, all I'm doing is just designing my Chainlit user interface. So if I want to quickly go through it, just like the session state variables in Streamlit, in Chainlit, what you can create is a user session argument that can get any input. So this is the way that you can have argument that might change while you are chatting with the chatbot, and this is how you can store them and interact with them to design your system. So I have session time. So as I showed you, we are going to use it for creating our memory. As soon as you open a new session, this session time is going to pick up the session time in Unix format and give it to the function that creates the memory for us. Then I have chat history. So this is where I'm going to pick up the Q&A, each Q&A, and pass it to a function to write it in our CSV files. Then I have a user session called RAG-LLM, which is false for now. So in my system, just to double check that whether I have to execute this piece here, I'm going to double check it with one of those arguments, RAG-LLM. So as soon as we create a vector database and we start asking our questions starting with 2 stars, this RAG-LLM here is going to be true. I'm going to change it to true while I'm coding. And as soon as we stop asking questions that starts with 2 stars, this argument here is going to switch to false. So this is just me making sure that if by any chance you hit 2 stars in your prompt and you start coding, it doesn't confuse our system, and our system performs consistently. I'm also providing some avatars for the model's response. So it's going to have OpenAI logo, and for the user's query, I'm going to have the AI Roundtable logo. So I showed you the data folder, and this data folder is going to contain one or more than one vector databases depending on how many websites you are asking the chatbot to prepare for you for Q&A. One thing that happens is as soon as you start a new session, it checks this directory, and in case there is any vector database in that directory, it's going to remove all of them. So it's just some sort of a cleaning, so you don't have a big data folder, and as you move on with your chatbot, that folder is going to stay clean and you can always start fresh and chat with a new website. I'm also going to create the memory folder for you automatically, and we are going to see the first prompt from the chatbot, which is, hello, welcome to WebRag query, how can I help you? So if I execute this code, we should be able to see this input message, this welcome message here. Hello, welcome to WebRag query, how can I help you? So up to here, this is just for designing the user interface. I just noticed that we have an error here that I just didn't want to fix it before moving on, but I want to show you actually if you see the same error, how you can solve it. Because I created a README file here called helper.md, and if you open the README file, you can see how you can solve this error here. So in case you see only one usage of each socket address is normally permitted, what you can do is, depending on your operating system, go through this guidance here and clear that socket address so you can execute your chatbot again. So let's see how I can do this. I'm hosting my chatbot on port 8000. So that's why I have the example here for port 8000, and I'm on Windows. So if I execute this code, I'm going to see that my port is now listening to this one. And what I can do here is, again, if you continue reading, you can see that once you know which application is using the port, you can decide if you want to close it. So for closing it, you can just change it like this. So the process with PID 14084 has been terminated, and right now if I execute my application, I should be able to have it without any issue. Let's double check. Perfect. So this is something that might happen to you as well, and you have the guidance for solving it for Mac OS, Linux, and Windows on the top. Okay, let's continue. One quick note, in Chainlit, if you want to access the user's query, this is how you can do it. So as soon as the user sends a message, you can take the message from message.content. So message.content gives me the user's query. So in the project, there is one common feature for all the branches, and that is the user session memory. The way that the user session memory is designed for the chatbot is essentially it has three main steps. The first step is that we are going to create a database, which in our case, for simplicity, I created CSV files. Then we have to collect the user's prompt along with the model response. And the model response can be from any of these four GPT models, either GPT RAG, GPT function caller, GPT web, and GPT summarizer. And then I have to start updating the CSV file. So this is where I'm going to write the memory database. And then whenever the user sends a new prompt, I have to check the database. And in case there is a chat history, because remember, for the first two messages, or for the first couple of messages until you start updating your CSV file, you won't have access to any chat history. Or after the first message, you will have access to the chat history just partially. So the model starts checking whether the chat history exists, and it is going to load the chat history, and it's going to process it to feed it to the next GPT model. So let's see how it happens in the project. First, how I'm going to collect the chat history is through this user session variable here. As you can see, it is an empty list. For now, it is empty, and every time that the user sends a message, whenever any of the models generate a response, we are going to collect them together, and we are going to write that in our memory here. So here is where I'm reading the memory, but let's keep it for the last. Let's say here, the first model, which is LLM function caller, gave me a direct response. So I will explain different scenarios, but here is when the model just decides to use its own knowledge. So in the chat history list, I take a tuple which contains the user's query along with the response that was generated for that query. So this is the response that the user is going to see on the user interface. This is the final response of our models. So I have this tuple. What I need to do is then start writing that tuple, that chat history list, this Q&A pairs, into my memory database. So this is how I'm doing it, by using this function, write chat history to file. And this function is getting chat history list, which we just created here. Or actually, since now this is highlighted, you can see that I'm creating it anywhere in the project, depending on which one of the models gave me the final response. And it also receives the path. For the path, it is receiving the path along with the session start time. So if you check the config file here, you will see that my memory path is memory, which is a folder here, then slash, then chat history underscore an empty string.csv. So when I pass dot format and I add this session start time, what I'm doing is I'm adding that session start time here into this bracket. Let's go into the function. So into the function, I'm creating a data frame, and that data frame contains the chat history list, and it contains two columns. The first column is user query, and the second column is response. Then I check if the CSV file exists. If it exists, I simply update the CSV file. If it doesn't exist, which means this is the user's first query, so remember, before the user sends the first query, there is no need to create a memory or save a memory anywhere. As soon as the user sends the first query, it is going to be triggered. So it's going to create a file with that name that includes the chat history along with the Unix timestamp that represents the start time of our session. And then it is going to write the memory into that CSV file. So let me show you actually how that memory looks like. So this is how my memory looks like, and as you know, so this is a CSV file, so we are not going to have a nice overview of the memory immediately, but if I start expanding the columns, you will see the user's query here. So in this case, there are only two queries: summarize this web page and give me a comprehensive summary for this URL. And as you can see, I have a response here, which is the model response. So I don't know exactly which model created. Actually, by looking at the prompts and queries, you can understand which model was triggered to give us the response, but that's not important. The important part is we have the response also in the second column. So what happens is every time that the user sends a new message, that new message is going to appear here along with its corresponding response. And every time that the user sends a new message, before processing the message and passing it to the model that needs to be executed, what we are going to do is we are going to open the session and we are going to look for the previous chat histories, get them, process them, and add them to our input to the GPT models. So let's see how we can do that. Here I am again in the code, and if I go back to the first function that I showed you, read recent chat history. This is where, as soon as the user sends a new message, the first thing that I'm doing is I'm collecting the message, of course, and then I check for the memory. So what the function receives is the file that is related to our current chat session, and then the number of entries. So this is the number of previous Q&A pairs that I'm going to collect in order to process and feed it to the GPT models. So it depends on how many of the previous chat history you want to collect and give it to a GPT model. Honestly, I don't think too many entries would be would improve the performance. But what I personally do is usually I take it as a 2 or 3, maximum 4. When I think about how I'm chatting with a chatbot, it doesn't need to remember what I said in the previous 5th prompt, but most probably what I said like in the past 2 or 3 prompts might be related to what I'm going to ask next. So let's see how this function works. So it's going to get those arguments, and actually this is the function. So read chat history, yes, this is the function. So it is going to get those arguments, and the number of entries in my case is 2, so I'm collecting 2 pairs of Q&As, and then I'm just keeping them in a list. That list is going to contain the column name, which is the user's query and response, and the column value for each row. And then I'm going to pass that list and I'm going to keep it as my chat history. So in chat history list, I have a list, and what I have to do next is to convert it to a string so I can pass it to a GPT model, and input chat history is the variable that I get to any of those models that are going to be triggered. So you will see it here, you will see it here, and you will see it here. You will also see it here. So 4 models, actually 3 models are going to be triggered here, which is LLM RAG, LLM Web, and LLM function caller. So I'm not passing it to LLM summarizer here, so what you can do is you can also add it to LLM summarizer. Well, now that I'm thinking, it makes sense because that LLM summarizer is eventually going to summarize a web page, and I'm not sure how having a chat history would help it. So for now, I'm not passing it to LLM summarizer. So just to correct my explanation, the chat memory is going to be added to this model here, to this model here, and to this model here. So this model here is not going to have access to the chat history. And now that I'm checking it again and going through like the logic behind it, it actually might be unnecessary to pass the chat history to that model. Well, anyway, this is like the functionality of this model is perfect to me, and I get what I want from it. So I actually doesn't need to pass the chat history. But if you think you would expect a response that might be somehow related to your previous prompts, you feel free to add the chat history to this GPT model as well. So I just explained the memory of our chatbot, and now from the top I will start going through the code, and I will explain every one of those functionalities. So the first thing is I'm getting the user's content. For any of the scenarios, this is the common section for all of them. I get the user's query, I collect the chat history, and I just simply put the chat history, wrap it in a string, and then I will explain this later, and then I prepare the message for the first GPT model. So this is my first GPT model. Remember, this model is somehow the main agent in my chatbot. This is the model that decides between 4 different functionalities, and actually for one of them it has access to more than one function. So this is a very important model in our chatbot. The first behavior of this model is when it decides to use its own knowledge. So let's see how it can happen. So in order to prepare the message for the model, I prepare it like this. I have a chat history, then it follows by the chat history, the previous 2 chat histories in my case. Then I have the user's new query, and it follows by the user's new query. So I wrap it up in a list. This is the typical input for a GPT model. I add the LLM function caller system role, and I add the query. So let's see the system role. LLM function caller system role. As a chatbot, your goal is to respond to the user's question respectfully and concisely. Feel free to answer the users from your own knowledge. So this is just a green light to the model that you can use your own knowledge. However, if the user's query needs to be answered by searching over the internet, return the best function to serve the user from the provided function. So right now the model doesn't necessarily know that those functions, all of them are going to be executed on the internet or not. But the most important part for me is the model knows that if the user query is somehow pointing to a functionality that is outside the boundary and the power of that GPT model itself, it is going to look over the functions and is going to pick the most relevant function for us. So that relevant function might be the summarizer, it might be any of the functions that can search the web for us, or any other function besides using its own knowledge. So just by simply telling it that you have access to the functions, and if the user query is somehow out of the box, just go and find the best function for us. So I'm passing the message to my LLM function caller. I also pass the temperature, and I also pass the GPT model. So I'm using GPT 3.5 for all of our models in this chatbot. As you can see, this model also gets as the input the wrap function result. So what is the result of this function? It is a list of JSON formats of all our functions that we want our model to have access to. So this is what I explained earlier, and this is how I'm passing these functions to my GPT model. The JSON format is going to be the input. Let's see what is happening here. So this is the prepare message, and in ask, simply I'm calling the GPT model the typical chat completion function, and I'm passing all the arguments. In case the model decides not to use a function but to use its own knowledge, what happens is it's going to ignore these two arguments. So if the model gives us the response itself, what happens is from here up until here, nothing is going to be triggered. So from here, we are going to jump over here. So I added a comment, no function was called, LLM is using its own knowledge. Or better to add LLM function caller is using its own knowledge. Then I have LLM function caller response. I just extract the text out of it, and then I print it for the user on the user interface, and I also collect it in my chat history. So let's see this functionality in the chatbot. So this is my chatbot, and if I want to make the chatbot to use its own knowledge, I can again ask a coding question. So give me a Python code that can compute factorial. So here is a Python code that can compute the factorial of a number, and you can see that it just also gave me the function. And what happens in the chatbot is the most important part is, first you can see that the session was fresh, so we didn't have a memory for it, so we just created a memory after the first prompt. This is something related to the memory part that I explained. And what happens here, you don't see any function in the output of the chatbot. So if there was a function in the output, I was going to print it. So there is no function, and the model just used its own knowledge. The second scenario is when this GPT model decides to call out a function. So as soon as the GPT model calls a function, which means these two arguments were triggered, and right now in the output of the GPT model, I cannot have access to any piece of text. So if I just execute this part, it's going to throw me an error, but I will have access to a key called function call. So as soon as I see the function call in the keys of the model's response, I know that the model just called the function. So this is where the other scenarios can happen. Let's go through the first scenario. The first scenario is when the model calls a function. It can be any of the DocDocGo functions, and that function is going to use a search engine and give us the result from the search engine. So the red functionality is exactly similar as Web-GPT that we designed in the previous video. So what happens here is I get the function, I just print out the name and the arguments. What I do is I pass the model's response to prepare functions.execute JSON function, and I get the function result. So I explained earlier, but this is just a mapping that checks the name of the function in the GPT function caller output and all the functions that I allow to be executed here. So it checks the name. If that function exists in my allowed functions, it is going to execute it in Python, and it is going to return the result. So as soon as it gives me a function that is searching the web using the DocDocGo search engine, I will get the search results here. And what I will have is, so this part is going to be skipped. What I will have is, I will pass that result to this LLM web here, and I will get the response from this model. So this is this model here. So again, of course, I'm preparing the input of the model, the result from the web search, the user's query, the system role, and the chat history. So if I open up the prepare message, you will see this is how I'm preparing the input. The chat history, search result, user's query, and the system role. And eventually here I'm passing all of them together in the second dictionary in the list. So LLM Web just received the input, which contains the web search results, and what is giving me is the response to the user. So the next step is I print the response in the user interface so the user can read it, and I also collect it in the chat history list so I can update my chat history. Let's test this functionality and see again how this works, and also see what is happening in the backend. So if I ask a question, I am looking for open source large language models, give me some relevant websites. So this is where the model is going to pick up one of those functions. It is going to search for us. So it is giving us OpenAI, Hugging Face, research.google, and ai.facebook.com. So probably very good response to what I asked for. And let's see what happened here. So our LLM function caller called the function this time. It didn't give us the answer itself. The function that it called was retrieve web search results, and it also added the query, which was open source large language models. So it modified my input and it passed it to a function, and that function searched this phrase on DocDocGo search engine. These are the results of the web search, and this is the input to my second model, this model here. So if we check, we have web search results, we have user's new query, and I also should have the chat history. So this is also the chat history from the previous Q&A that we just had with the chatbot. Web search results is an empty string, but it is receiving the web search result. It is just not picking it up in the input here, but the chatbot is actually able to see it, and that is how it is able to provide us with this answer. So if I open the website, this is the OpenAI website. So this was the second scenario where we just simply had Web-GPT, and that is going to search our query on the web, and it's going to give us the answer based on the web search. Third is when I ask the model to prepare a specific website for Q&A. So this is where we are going to create this vector database, and we are going to design our RAG side of the system. Let's see how that can happen. So the query is going to be passed to LLM function caller. LLM function caller is going to call out a function, and I exactly know what that function is. And that function is prepare the requested URL for Q&A. That function is going to be executed among all other functions that we have. So if I open this function here, I will see it here. So as soon as the model returns this function, it is going to be executed here. And by executing this function, it is going to go through the whole backend of preparing the URL, preparing the vector database, saving the vector database. Everything is going to happen using this function. So this function is simply getting the requested URL, but a lot of things are happening in the backend, right? So there are two classes that are going to be called, and eventually what I will have is a vector database ready in my data folder, and I can start asking questions about that vector database. So let's test it and see how that works. Prepare this for Q&A, and in order to give it a website, I will give it actually LLM 0200, because there are a good chunk of information in this web page, and we can see how effective is the RAG side of our system. So as soon as the vector database is ready, since the user still hasn't asked any proper question about the vector database, what I'm showing the user is just simply, sure, the URL content was processed. Please start your question with 2 stars if you want to chat with the URL content. So how it is happening here is that function was executed here. So here I processed the website, I created the vector database, and I saved it. And here is actually our vector database. You can see it was created in the data folder. And then, since the user still didn't ask any question, I just double check if this was the function that was called you know what, just show the user that the vector database was created, of course, print it in the user interface, and also save it in the chat history. And then what happens is the user can now start asking questions. So let's ask a question. Of course, we start with 2 stars. What I'm going to ask is, explain Web-GPT. Simple. Web-GPT is a powerful tool that allows users to ask questions that require internet searches. It leverages GPT models to identify and execute the most relevant Python functions in response to user queries. The tool has a user-friendly interface with a Streamlit, so it was able to exactly pick up all the key informations related to Web-GPT. And if I open my website here, you can see that Web-GPT was explained here, and the model was just able to pick up the relevant information from here. Let's ask a second question. Let's ask actually, what are the tutorials? Forgot the 2 stars. So the tutorials available on the provided link are LLM function calling and vectorization tutorial. And for more details, it just gave me LLM 0200 project directory. So that's perfect. Again, it was able to pick up the tutorials, the title of the tutorials. I'm sure if I ask about more information, it is able to pick it up. So this is a perfect RAG system with our website. And this is how I can start asking questions. And I mean, in case the website is long and it contains a lot of unnecessary information and you just want a specific piece of information, this is perfect, right? This is what just gives you the ability to quickly get the answer that you're looking for. So this is the RAG side of our system. Let's also see the backend. So let's see what happened when I initially passed the website to the model and asked it to prepare it for Q&A. What happened was the first GPT model, the function caller, called this function, prepare the requested URL for Q&A. And it passed the URL to my function. Then LangChain in the backend processed the website. Number of chunks are 20. As I said, actually that project has quite a good amount of information on it. And then it prepared the vector database and it saved the vector database locally. From here, I started to ask questions about the vector database. That's why we don't see any information here, because in this branch, I'm not printing anything. I just simply ask questions. That questions is going to be searched on my vector database. Then the retrieved content is going to be passed on the GPT RAG, and GPT RAG is going to give us the answer. So this is an important part of the project that makes RAG possible for us. So if I check the code, as soon as the user asks a question that starts with 2 stars, so this part here is just double check that that is not the case, which right now it is the case. So it skips all these steps up to here. What happens is we know here that the user message started with 2 stars. I'm going to find the latest Chroma folder. So if I just ask the GPT model to prepare a second slide, since I'm developing this project locally, I cannot just simply remove the previous vector database. It's still attached in the backend, so it will throw an error. What I do is instead, as you know, as you can see, the name of the vector database also contains a unique timestamp. So I simply find the latest vector database and I point to that database. So in the next step, we are going to prepare the message for LLM RAG, and this is where I'm also searching over the vector database. So let's see what happens here. It gets the user's query, chat history, the directory of our vector database, and what it does is first, it uses the user's query to search over the vector database and get the retrieved documents, and then it is processing the retrieved documents along with the user's query and input chat history for the input of the GPT model. In the next step, I'm going to pass that input that we just created to the LLM RAG-GPT model and get the response in the output. First, I'm going to print it for the user, and then I'm also going to get it for the chat history. So we just went through scenario 1, scenario 2, scenario 3. We also saw the RAG side of our system, how we can start a query with 2 stars and actually perform RAG. Then there is one last functionality for our chatbot that remained here, which is summarize the web page. Let's see how it is happening in our code. So I send my query, which is something around summarize this URL, or give me a summary, or I want to know more about this URL. Any of those would most probably trigger that function. It goes through the first GPT model, the function caller, and the function caller is 100% going to give us a function in the output. And that function in the output is going to be summarize the web page. So what happens again is that function is going to be executed somewhere here. Here it is, summarize the web page. So if the function caller gives me summarize the web page, it is going to be executed here. And by executing here, I mean we are going to load the content of the web page, we are going to create the documents, we are going to go over the documents, passing to a first GPT model, start summarizing each page, and then eventually give it to a second GPT model to give us the full summary. In the return in that function, we are going to get the full summary. So it means that if that function is called, summarize that URL, like summarize the web page, this func result here will be actually the final summary that I'm looking for. So what I need to do is to just check whether that function was called. In case it was called, I will simply print that function result, which is the final summary for the user, and also I'm collecting it, I'm getting saving it in the chat history list. So this is the last functionality of our project, and let's see how it works on our chatbot. You know what, let's create a new chat. So this is how you can create a new session here, and as soon as I start my prompt and as soon as I send the first prompt, there will be a new CSV file for my memory. Let's say summarize this website, and let's give it again the GitHub repository. So this is going to call out summarize the web page. So this is the function that was called, and as I said, we didn't have any chat history, so that's why we are seeing this error here. I have summarized the web page, then I also have the argument, which is the URL of the web page. The website length is 1, and then generating the summary. Page 1 was summarized, full summary token length 92. So if you check Web-GPT, I explained how I'm somehow managing one of the issues that this function might have, which is giving me a summary which is above the permitted context length. And actually for the website, the problem is even less likely to happen. And most probably it's going to be able to just give you the summary, because I mean, how many pages would be in a website unless you pass a paper, an open source paper to the model. So this is not going to be necessary here, but anyway, since I'm using the exact same function in Web-GPT, so I didn't touch anything, so it's also printing that and it's calculating the number of tokens in the output. And let's check the summary. The repository is a collection of various use cases, LLM chatbots, RAG-GPT, Web-GPT, etc. So again, we saw that summary earlier in the video too. This is just a very nice summary of this URL. So I explained every scenario here, and I showed you how each one of them can happen in the code. In the next step, again, since we collected the chat history for all of our functionalities, we are going to write down the chat history, and eventually, in case anything happens with the chatbot, I'm going to show the user this message: an error occurred while processing your query, please try again later. And also I'm going to print the main error, like the error and the traceback in the terminal, so I can start debugging it. So that was it for WebRag query. I know the project was a little bit more complicated than before, but actually if you have already seen Web-GPT and RAG-GPT, it should be very easy to understand, and it should be very easy for you to start modifying the project and adjusting it for your needs. One last note is, as you can see, this chatbot is also able to somehow, in a sense, scrape the websites. So this is just a note from me, just to use it properly and to make sure that the websites that you are passing to this chatbot are actually you can do it legally, let's say. I will keep it just that simple. And beside that, enjoy using the chatbot, enjoy just make your web search faster and more effective. So thank you very much for watching this video. In the next video, I'm not sure if I'm going to prepare the multimodal chatbot, which is a chatbot that understands text, voice, and it can generate text, voice, image, and it can also understand image, so it can give you an image summary in the output. So that's a chatbot that I'm still working on it. Actually, the chatbot is almost ready, but there is an idea in my mind which might make it much more interesting. So I might postpone that chatbot for now until I can update the code and apply that new modification. What I'm thinking is probably I will start by explaining fine-tuning large language models. And in the first video of fine-tuning will probably have 2 videos, but in the first video I'm going to show the full fine-tuning of a language model, probably not a large one due to computational power, but full fine-tuning of a language model. And then in the second video I'm going to go through fine-tuning a language model using a technique like PEFT, so we can start actually working with bigger models with that technique. So that's most probably for the next video, and I hope to see you in the next video.